Students, we are surrounded by air from all sides. The air stretches to about 60 kilometers above the surface of the earth. As the altitude increases, the air becomes thinner. The envelope of the air that surrounds the surface of the earth is called the atmosphere. Air has weight. The pressure exerted by the air is called the atmospheric pressure. Without air, no animals and plants can survive. We cannot see air. We can only feel the moving air. Students, now look at this activity. This activity helps us verify that air occupies space. Now let us do the activity. First, hold a blade of glass and dip it in a bucket of water, tilting it gradually. You can observe air bubbles coming out. As the water passes in the glass, it displaces the air. The air displaced by water begins to come out in the form of bubbles. Thus, we can prove that air is invisible, but it is everywhere and occupies space. Now, let us perform another activity and prove that air has weight. For this, you require long needle. Students, so take a long needle. Tie 2 balloons tightly filled with air and hang the needle from its center. Now pierce one balloon. As the air comes out, the other arm of the balloon goes down, showing that air has weight. Students, a body which has weight can exert pressure, and air occupies space and thus weight. Do you know that air can be compressed? Yes, air can be compressed. Let's look at this activity. Students, air can be compressed, and this compressed air can exert more pressure than the atmospheric pressure. Now, measure the weight of a ball. Fill air tightly in it and measure its weight gain. The weight of the ball increases. The ball can exert pressure and can also bounce. Students, the tires of cars and bicycles are filled with air. That is, air is compressed in the tubes so that it can exert pressure. The atmospheric pressure is most available at the ground level. That means at the sea level. As the altitude increases, the air becomes thinner and hence its pressure also decreases. We do not experience the atmospheric pressure because our body, that is, the internal pressure, balances the atmospheric pressure. The persons who have high blood pressure often suffer from bleeding nose at high altitudes. This is because body pressure could not withstand the atmospheric pressure. Students, does air has pressure? Okay, to find out, let us look at this activity. You take a glass tumbler and fill it with water. Place a cardboard on the tumbler and press it on the mouth of the tumbler, so that there is no air inside the tumbler. Hold the tumbler in the hand and invert it upside down as shown in the figure. The cardboard does not fall. The pressure exerted by water in the tumbler on the upper surface of the cardboard is less than the atmospheric pressure exerted by atmospheric air on the lower surface of the cardboard. Due to this reason, the cardboard does not fall. Now look at this activity. The statement says, air exerts pressure on all sides. Let us do this activity and find out whether the statement is true or not. Students, take a rectangular tin can and put little water in it. Heat the water so that it begins to boil. By this time, all the air is removed from the tin can and there is partial vacuum. A place where no air exists is called vacuum. Now close the lid and let the tin can cool. After some time, you will notice that the tin can is crushed from several sides. Students, before heating the tin can, the air pressure outside and inside the tin can was equal. the pressure inside the tin can is reduced by heating, and thus atmospheric pressure is extremely high. The atmospheric pressure acts on all the sides of tin can, and it is crushed. As the altitude increases, the atmospheric pressure decreases. In the aeroplanes, the atmospheric pressure is maintained to normal temperature and pressure. The normal atmospheric pressure is 760 mm of Hg, that is, mercury at sea level. Now, let us move on to another activity, which states that air has atmospheric pressure. Let us verify that. Students, you need a glass filled with water and a straw. What you do is take a glass filled with water and with the help of a straw suck the water. As the air is passed in the mouth, the water level rises in the straw. The atmospheric pressure is acting on the open surface of the water in the glass. This helps maintain the water level in the straw also. The same principle is applied while filling ink in the pen. Students, the syringe that is used for injecting medicine works in the same principle. Look at the given figure.